So in this lecture, first we'll be trying to understand how to resolve a vector into its Cartesian component form. Now for this, we consider a Cartesian system with x, y and z direction or z axis, where this is the x-axis, which is not mentioned in the figure. This is the y-axis and this is the z-axis. Now, if a1, a2 and a3 are the scalar components of a vector OP bar, here is the vector OP bar, which is also represented by a bar, and along x, y and z axis respectively, then the vector OP bar, that means a bar, is given by a bar is equal to I cap a1 plus j cap a2 plus k cap a3, where I cap, j cap and k cap are the unit vectors along x, y and z axis and are called basis vectors, which are mutually perpendicular to each other, because as x, y and z axis are mutually perpendicular to each other, and since I cap, j cap and k cap are the unit vectors along these three directions respectively, so they are also mutually perpendicular to each other. Now let us explain this mathematical expression a little bit more. Suppose you have started moving from the point O along the x-axis and you have traveled a distance a1 along x-axis. So as I cap is the unit vector along x-axis, the vectorial distance that will be traveled by you along the x-axis will be I cap into a1. Now suppose from this point you have changed your direction and you have started moving along y direction, and suppose you have traveled a distance a2 along y direction. So the vectorial distance traveled by you along the y direction will be j cap into a2, where j cap is the unit vector along y direction. And now again, suppose from this point you have changed your direction and you have started moving along z direction, and suppose you have traveled a distance a3 along z direction. So the vectorial distance that will be traveled by you along z direction will be k cap into a3, as k cap is the unit vector along z direction, right? So in this manner we have got three vectors. One is I cap a1 along x-axis, one is j cap a2 along y-axis, and another is k cap a3 along z-axis. So the resultant of all these three vectors can be obtained by adding the tail of the first vector, which is nothing but the tail of the vector I cap a1, that is the point O, to the head of the last vector, that means k cap a3, and which is nothing but the point P. So if you connect these 2 points O to P, then you'll be getting the resultant of all these three vectors I cap a1, j cap a2 and k cap a3. And this is nothing but, this OP is nothing but a bar. And here it is written, a bar is equal to I cap a1 plus j cap a2 plus k cap a3. Now coming to the dot product between these three unit vectors I cap, j cap and k cap, they actually abide by the following rules. I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1. And also I cap dot j cap is equal to j cap dot k cap is equal to k cap dot I cap, and these are is equal to 0. Now coming to the cross product between these unit vectors, you can see I cap cross I cap is equal to j cap cross j cap is equal to k cap cross k cap is equal to 0. And also I cap cross j cap is equal to minus j cap cross I cap, and this is equal to k cap. Now why k cap? Because k cap is the unit vector which is perpendicular to both the unit vectors I cap and j cap. Similarly, j cap cross k cap will be is equal to minus k cap cross j cap, and this will be is equal to I cap because I cap is the unit vector which is perpendicular to both j cap and k cap. And also k cap cross I cap will be is equal to minus I cap cross k cap, and that will be again is equal to j cap because j cap is the unit vector which is perpendicular to both k cap and I cap. Now, dot product in Cartesian component form. That means we now need to know how to find out dot product between two vectors in its Cartesian or in their Cartesian component forms. So here we are considering two vectors a bar and b bar, and the dot product between them, that means a bar dot b bar, can be written in their Cartesian component form as I cap x plus j cap ay plus k cap az whole thing into I cap bx plus j cap by plus k cap bz, where I cap x plus j cap ay plus k cap az is nothing but the Cartesian or nothing but the expression of the vector a bar in its Cartesian component form, with x, ay, az are its scalar component along x, y, and z axis respectively. And similarly, I cap bx plus j cap by plus k cap bz is nothing but the Cartesian component expression of b bar with bx, by, bz as the scalar component of b bar along x, y, and z directions. And if you do the dot product between these two quantities, then easily you can see that it will be is equal to ax bx plus ay by plus az bz. Now this mathematical expression immediately leads us to the rule about how to find out the dot product between two vectors in their Cartesian component form. And the rule states that to calculate the dot product, multiply the like components and then add. That means if we need to find out the dot product between two vectors in their Cartesian component form, first you multiply their like components and then add them. Right? Now, how to find out the magnitude of a vector? Suppose a bar is a vector, so the dot product of a bar with itself, that means a bar dot a bar, will be is equal to a square, because a bar dot a bar will be is equal to a into cos 0, and that is equal to a square. And this is again will be is equal to x square plus ay square plus az square by following this statement, right? So a will be is equal to root over x square plus ay square plus az square, which is nothing but, this a is nothing but the magnitude of the vector a bar. And also you can notice that this is nothing but the three-dimensional generalization of the Pythagorean theorem. Thank you.